here's a problem. Y has two independent variables. Right, x and t. Y is a function of x and t, and you can move either one however you want. You can move around in space, or you can wait for something else to happen in time. So let's look real quick at how we deal with that. So let's look at the old thing you know and love called the total derivative, or just the derivative. You call it the derivative. It's actually the total derivative. And you take a derivative when you have something that varies with one independent variable. So you write it like this, dy dt, with a big normal good old-fashioned d there and a good old-fashioned d there. And you know that equals, and the way we define it is in the limit of delta t as it approaches 0 of y of t plus delta t minus y of t over delta t. Only mathematicians could make the slope look so ugly, right? So keep in mind, all this is the slope. This is the rise, this is the y, the height at one point, and the height at a farther along point. The difference is the rise, and delta t is the run. It's just the rise over the run. And the limit means that's what it is at one point. Okay, so don't let the mathematicians make it so confusing that you don't know what they're talking about. So the total derivative, and it's called the total derivative because that's the biggest change, that's the only change you'll get, because it only depends on one thing. All right, so now we're dealing with something called a partial derivative. Okay, and it's called a partial derivative because we're going to calculate the change, but we can only do it for one variable at a time. Therefore, it's not the total change. Both variables, independent variables, might change. But what if we can only think about one at a time? So again, we're doing this because we have y of x and t. So let's see what it looks like. You actually use a different symbol, dy dt. This thing is called a d, and it's not a cursive d, and it's not a regular d, it's not a delta. It's a special symbol made up for partial derivatives called a d. Okay? Most math programs, you know, have a d in them. You can probably get away with using a delta if you're being sloppy. Okay? So let's define this partial derivative. It is also the limit as delta t approaches 0 of y of x at t plus delta t minus y x t over delta t. That's it. Basically, to take a partial derivative, all you do is hold the x constant. Treat the x like a constant, take the derivative with respect to t. So dy dt, hold x constant. If you want a dy dx, hold t constant. So taking partial derivatives is not hard. It's about as hard as taking regular derivatives. You just treat the other independent variable as a constant. Solving partial differential equations is hard. That's what we're about to do. But just taking them, actually, in terms of the mechanics of it, is really no different.